Hey guys, welcome to Unit 1, Day 15. We're going to be talking more about the measures of center today, so consider this part 2 of our discussion about the measures of center. Remember that the goal for a measure of center is to find the center or the typical value that would occur in a data set. All right, so today our goals are to learn how a statistic can be resistant. We mentioned that word in yesterday's lesson, but we need to explain what that word actually means. And we're going to understand the relationship between the mean and the median and the shape of the distribution. So we're going to be taking a look at a couple of examples of that. And then we want to understand when to use each measure of center. All right, so we're going to talk about those three things. So let's get right into it. Let's get into this idea of resistant measures. All right, so what does it mean for a measure to be resistant? And we say that a measure is resistant if it is not strongly affected by extreme values. All right, so just to demonstrate that, I've got a couple of data sets here, and you'll notice the difference between the two. I have a very small data set, 1, 3, 3, 7, and 9, and we're going to find the mean and the median. And then in this data set, it's the same exact data set, but I added a very large value here, one that would clearly be an outlier of 1,000. And then we're going to recalculate the mean and the median to see what effect that 1,000 had on both of those measures. All right, so let's give it a try. I'm going to kind of set this up here. So we're going to find the mean, and then we're going to find the median, right, for both of these. And we'll be able to see what happens. Okay, so I'm going to take my data set, I'm going to hit Stat, I'm going to go to Edit, and you'll notice that I already have all of my data entered into the different lists. So we're going to be dealing with 3 different sets today. So here's the first one, 1, 3, 3, 7, 9, and then here's the second set of data, 1, 3, 3, 7, 9, 1,000. So you'll enter those in, and then we're going to go to Stat, and we're going to go to Calc, and I'm going to use one-var stats to find these two things for me quickly. All right, so I'm going to hit Enter. I'm going to do the first list. That's the one without the extreme value, or without the outlier. Let's see what we got here. So we got a mean of 4.6. And then I'm going to scroll down to get my median. So my median is 3. All right, so now let's do the same thing, but we'll add in that 1,000. So I'm going to do one-var stats, and this time I'm going to do it on list 2. Remember, list 2 just includes my extreme value. There we go. And let's look at what happened here. So we have a mean of 170.5, and then our median. And here our median is 5. Okay, so there we go. So we got the mean and the median for both sets. And you might be noticing here, like, wow, adding in that value of 1,000 had a very large effect on the mean. It went from 4.6 to 170.5, but the median didn't really change a lot at all, right? The median was 3, it changed to 5. So the effect that 1,000 had on the median was much less of an effect than what it had on the mean. All right, so when we say which measures, the mean or the median, were not strongly affected by the 1,000, by that data value of 1,000, the median was not, right? So we would say the median is resistant. Okay, so that is what it means for a statistic to be resistant. The mean obviously was greatly affected, so it is not resistant. We made sure that we noted that in our notes from yesterday. The median is considered resistant. All right. All right. So we kind of get into this discussion of which measure of center is best, and it depends on a lot of different things, but it depends on the type of data, the nature of the population that you're studying, and whether or not you're going to decide to include outliers in your study. So a lot of times, like if we had a data set like this where we can see 1,000 is clearly an outlier, we would go and investigate why that outlier happened and then make a decision as a researcher as to whether or not we would include that outlier in our data set. Like, is it a legitimate reading that we need to talk about and that we need to include in our study, or was it a mishap or a blooper that we can just kind of exclude from the data set? All right. So that decision really determines what measure of center you're going to use when you do your study. All right. So the mean is used on discrete or continuous data, but it is most often used on continuous data. All right. So continuous data likes the mean. All right. It's good for data sets that are not skewed. All right, so if we have a data set that is being skewed in one direction or the other, or if it has any of these outliers, all right, we want to not use the mean for those types of data sets because those extreme values tend to pull the mean away from the typical value of the data set. All right. Now, the mean is the most commonly used measure of center, and we'll see that as we progress through the course, but this is the one that is most used. If you ever read a research study, most likely they are going to be using the mean as their central tendency. Right now, the median can also be used on continuous or discrete data sets, but it's more commonly used with discrete data. All right. It is better than the mean on data sets that are skewed or have a lot of outliers. All right. So if we see a skewed distribution or we have a lot of extreme values in our data, examples of that might be like studying incomes, especially in America where we have a lot of people in our population that have very extreme amounts of wealth. And then we also have a lot of people too that have next to nothing. Okay. So those are the kind of values that can really skew a data set. And in most cases, most of your statistical reporting agencies out there, when they report on something like income, they use the median to do it, right? So the median income is much more reliable than the mean income because of those outliers, all right? The last one here is the mode. We don't really talk about the mode a whole lot because it's rarely used. In fact, the vast majority of the time that the mode is used, it's used for nominal or qualitative data. You know, things like hair color, eye color, race, religion, things like that you would observe that are non-quantitative types of data, all right? However, the mode does have the benefit of being resistant. It is not affected by extreme measures or outliers, all right? All right. Now, the next thing we're going to talk about here is the mean and the median and this relationship that they have and also the relationship that those two measures have with the shape of the distribution. Okay, so one thing that we notice when we get a distribution that is symmetric, what we notice there is that the mode, the mean, and the median will all perfectly meet each other. So if we have perfect symmetry, like what we see here in this histogram, when we have perfect symmetry, okay, then these three measures of central tendency will all be the same. So in a perfectly symmetrical data set, they will all work just fine. All right. Now, when we do something where we are skewed to the left, right, typically a skew happens because we have extreme values in one direction, right? So all of our data is kind of pulled up over here. That's why we see the hump over here. And then we have a few values going on over here. That's why the bars are really low here. All right. So these would be considered extreme values or possibly outliers. And what happens is as we put those outliers in, as we keep on adding more and more extreme values, it has an effect on the mean. It's pulling the mean in that direction off to the left. And what we see is the mean ends up being less than the median as it pulls the mean away, right? Because the mean is going to pull away faster than the median because the median is resistant. So the median's going to stay put while the mean gets pulled off to the left. Right, so if I were to know the mean and the median, right, and I knew that the mean was less than the median, that would indicate that we have a skew left distribution. All right, now on the flip side, right, let's say we have our extreme values over here on the right-hand side, right? So we have this skew left shape, right, with some extreme values over here pulling on the mean. It's pulling it over to the right, and it's going to pull the mean faster than it's going to pull the median. Okay, so the mean ends up being bigger than the median, and when we see that happen, when we see that the mean is greater than the median, we see a skew right shape. Okay, so if without having to draw a histogram, we can tell what the shape of a distribution is going to be, whether or not it's going to be symmetric or skew left or skew right. Okay, so this is a very handy tool to have. All right, so let's take a look at an example. So I've got a data set here. We've got the number of months that patients typically wait on the transplant list before getting surgery. All right, so the data is ordered from smallest to largest. You're welcome. And we're going to calculate the mean, the mode, and the median. All right, so we're going to get all three measures of central tendency here, or of the center, and then we're going to compare the mean and the median and see what the shape of this distribution is without constructing a histogram. All right, so let's give it a try. All right, so if I were starting from scratch with this data, all right, I would be going to stats, right? I'd go to my stats menu here. I would then hit edit, and I would enter my data into a list just like you see here. All right, now I had all this entered in before I started the video because I didn't really think you wanted to watch me enter in 40 pieces of data. There's 40 individuals in this study. So all you have to do, you type the number, you hit enter, and it puts it in the list. All right, so you should be comfortable with doing that by now. All right, so to get my three measures of central tendency, what I'm going to do is I'm going to go ahead and hit stat. I'm going to go over to calc, and I'm going to use my one-var stats. And I'm going to make sure I tell it that I'm doing list 3 this time. So if you need to change lists, just hit second stat, and it takes you to all of your lists, and then you can select the one that you want to use. And then I'll just hit enter, enter. This frequency list thing, don't put anything in there. All right, just go straight down to calculate, hit enter, and we should get all the numbers that we need. Okay, so we got a mean, which is 14.15, so I'm going to write that down. And then we should have a median at 13.5. There we go. And then our mode, well, one of our stats doesn't tell us the mode, but I did very nicely sort the data for you here, so it should make it a little bit easier to find the mode. So let's go through here. We got 3, 4, so it looks like 7 repeats 4 times, 8 2 times, 9 2 times, 10 5 times. I'm going to make a note of that. And then 12, 13, 14, 15, 17 twice, 19 3 times, 22 2 times, 23, and then 24 4 times. So it looks like 10 is the winner here. 10 is the most repeated value. It's the one that occurs most frequently. So the mode is 10. All right, so you see how easy that was once it's sorted. Use the sort feature on your calculator to help you out with that. All right, so now I'm going to come over here and I'm going to say, okay, well, if I'm looking at my mean and I'm looking at my median, the mean is greater than the median, right? Because we have 14.15 versus 13.5. And if I recall from what I was just saying before, when we have the mean greater than the median, we are going to be skewed. All right. So I'm going to say skew right, but I'm going to say slightly. And the reason being is because really it's not that much bigger. In fact, you could even make an argument for it being slightly symmetrical, right? Or roughly symmetrical. So most cases, in fact, almost all cases, these two measures are not going to be exactly the same. They might be really, really close. And in that case, when they're really close, it's perfectly acceptable to say that they are roughly symmetric or slightly skewed. All right, so either one of those descriptions would be correct. All right, guys, that's it for today's lesson. If you have any questions, make sure you let me know in the Zoom chat. I would love to help you out. Otherwise, have a great day. We'll see you tomorrow.